Hi everyone, in this video we're taking a look at two rational inequalities. We're going to use the same four-step procedure for both inequalities. In the first step, we're going to define a function f of x to equal the left side of the inequality. In the second step, we're going to figure out when the function we define in part A is equal to 0 or when it's undefined. A rational function is equal to 0 when the numerator is equal to 0. And it's undefined when the denominator is equal to 0. So we have the points 3 and -1. In the third step, we're going to draw a number line and test values in the three subintervals that we have. Testing 4, we see that that's going to give us a positive number. If I were to plug in 4 in the numerator, I get a positive number. If I were to plug in 4 in the denominator, I also get a positive number. Similarly, between -1 and 3, if I choose 0, I'm going to end up with a negative number. And between -infinity and -1, if I pick -2, I'm going to end up with a positive number. And now I note that the original question is equivalent to answering when f of x is greater than or equal to 0, and we can use part C for that. Greater than or equal to 0 means plus. I include the 3 because I have greater than or equal to 0. However, I cannot include the -1 because the function is undefined at that point. Continuing on with example 2, a rational function is 0 when its numerator is 0, and we find that that happens when x equals -5, and a rational function is undefined when its denominator is equal to 0, and that's when x equals 4. In part C, once again, we have a number line. We choose values in the three subintervals, and we fill out our number line with a plus, a minus, and a minus. And we note that the answer to the original question is equivalent to answering when f of x is less than 0, and that happens between -infinity and -5, and -5 to infinity.